we are going to derive these guys over here. The worksheet, again, is at the website, advancedmathtutors.com, if you don't have it. But we're just going to do, this is a chain rule practice number 1. It's some easier chain rule things. There's also a medium and then a harder one, so if you want to have some more practice. But just to run through these, number 1, if y is sine of 5x, then dy dx, or y prime, however you want to write it. By the chain rule is, we're going to derive the outside function. There's two functions here. Sine is the outside function. The inside function is 5x. You can see that because it's inside the parentheses. But to derive sine, you get cosine, and the inside part does not change. Cosine 5x. And then you multiply that by the derivative of what's inside of there, which is just 5x, so the derivative of that is just 5. And if you want, you can put the 5 out front, so it's really 5 cosine 5x. Alright, number 2. Same thing. We have a square root, and then inside the square root is another function. So we have this concept of an inside function and an outside function. To get y prime, dy dx, same thing. The first thing we're going to do is derive the outside function, which is to the 1/2 power. This is the same thing as x squared plus 4x plus 8 to the 1/2. So when you derive that, you derive the 1/2, so you're going to get 1/2 of this thing. The inside does not change. X squared plus 4x plus 8. And now the exponent, it was 1/2. We brought him down, we multiplied by the 1/2, and now you subtract 1 off of there, and that gives you negative 1/2. And now by the chain rule, we derive the 1/2 power. Now we need to derive the inside part, which is just a polynomial, so we can use the power rule on each one of these little guys. So x squared turns into 2x, plus the derivative of 4x is 4, and the derivative of 8, which is a constant, is 0. So the derivative of any constant is 0. And this negative 1/2, since we're multiplying all this stuff, we can really rewrite this as 1 over 2 times the square root of x squared plus 4x plus 8. And then 2x plus 4 is just being multiplied, so we can really just put that on top. 2x plus 4. So honestly, we don't even need this 1 out here, so you can just forget him. Doesn't really matter. But there you go. And if you're really, really feeling smart, you can cancel the 2 with the 2x plus 4 because everything's divisible by 2. So really, you cancel out that 2 and make it x plus 2 up top. So you could write x plus 2, and this would be your simplified final answer, over the square root of x squared plus 4x plus 8. Alright, so that's 1 and 2. Let's go on here to number 3. Okay. Number 3 is the 4th root of sine cubed of x. Well, right away, I'm just going to rewrite that. Okay, this is not deriving it yet. I'm just rewriting it. The 4th root of something cubed is the same thing as that thing to a power, which is sine of x. So you can think of it like this. It's really sine of x to the 3/4. If you think of it like that, it's going to help you use the chain rule here. G prime, now you can see the inside function is sine, the outside function is to the 3/4 power. So when we derive it, we're going to derive it to the 3/4 first. So we multiply by 3/4. Inside stays the same. Nothing wrong with that. And 3/4 minus 1 is negative 1/4. Times the derivative of the inside. Now deriving sine is just cosine. Okay, and now the calculus is done. We're just going to simplify here. Again, the negative exponent moves this thing to the bottom, so we're going to get 3 over 4 sine of x to the positive 1/4 now because we moved it to the bottom. You can write it as a 4th root if you want, and since cosine is being multiplied, he just goes on top. And there you go, you're done. You don't want to make cosine over sine like cotangent or anything like that because sine is to a power and cosine's not, so just leave it like that. There's your derivative. This is the function that gives you the slope of this original guy. Okay. Let's get rid of all this junks. Goodbye, junks. Okay. Number 4 is tangent of secant. So we're going to derive the outside function first, which is tangent, and the derivative of tangent, so this is 4, the derivative of tangent is secant squared. So we're going to get secant squared, and the inside stays the same, which is secant of t. So we derive tangent. There we go. We got secant squared. Inside stayed the same. Now we need to multiply by the derivative of the inside. Well, the derivative of secant, which is the inside from over here, okay, there's secant right there. Deriving secant, it should go right here on the right here, but I'm going to run out of room, so I'm going to write it underneath. So it's times, and the derivative of secant is secant of t tangent of t. So your final answer is secant squared of secant t times secant of t times tangent of t. And you cannot combine the secant t tangent t. Secant squared times secant t. You cannot combine those. It's not secant squared times secant. Alright? It's secant squared of secant. Very, very different things. Okay, so there's nothing you can do with those. What's up, man? Nope.
She's going to be here.
She's not here.
Drop
You can drop it off. She'll get it. Alright, number 5 is very similar, except now secant's the outside function. What's up, y'all? So we've got, what, dy dx, and deriving the outside function, which is secant, the derivative of secant is secant tangent. So we're going to get secant of the inside. The inside is not changing, which is tangent x. So it's secant of tan x times tangent of tan x. Alright, look at this over. Cool. So we've derived secant, you get secant tangent, but the inside part stays the same. That's why there's tangents inside these guys. And now we're going to multiply that by the derivative of the inside of the original. The inside is tangent squared, so the derivative of that is, inside is secant. See, Anthony. Inside is tangent, so we're going to derive tangent and get secant squared. There you go. So we have secant of tangent of x times tangent of x times secant squared of x. And again, you cannot put these things together because it's not times tangent. It's tangent of tangent. Okay.